Good morning, everybody. Welcome to day 2 of Next. Super excited to have you all joining for this session. My name's Jamie Guerre. I'm one of the product leaders in Google Cloud AI, working on Gemini Enterprise, the agent platform, and some of our developer tools. But I'm actually fairly new to Google and have spent most of my career working at startups. So really excited to be with this group today, with a number of startup founders in the audience and some esteemed colleagues on stage with me here today. Just to get like a pulse check, let me start with a quick question for everyone in the room. How many of you have built an impressive AI demo or prototype that completely failed and broke when you tried to deploy it in production for a customer? Looks like many in the room, and I've been through the same experience. I think a lot of us have. And that's the moment that like many of us eventually hit. The demo or prototype works beautifully, but the moment it hits production, you run into issues with unpredictable results, tool failures, runaway agent loops, and a lack of visibility into what's really happening under the hood. And in other words, prompts don't scale on their own. They need all of the system around them to succeed. And this is where we have companies like Temporal, GitLab, and Vellum, and really starting to build infrastructure that can help support all of that. So I'm excited to focus on that today and this infrastructure shift and the system that's really needed for multi-agent workflows. I'm joined by my colleagues Maxim, who's the CTO of Temporal, and George, the CTO of GitLab. We should have one more panelist joining in a few minutes as well. Maybe we'll start with quick introductions. Maxim, do you want to tell us a little bit about Temporal?
Yeah, I'm Maxim. I'm CTO and co-founder of Temporal. Temporal is an open source project. It's been around for over 10 years. We started at Uber, and it's MIT licensed. It's real open source, so you can try it out, but we can talk more about that. But it's kind of short version of that. It's resiliency as a platform. So if you need any resilient distributed application, obviously agentic ones fit that very well. You probably want to look at us.
Amazing. And George, tell us about your role in GitLab.
George Kichukov, field CTO with GitLab. I work with a lot of customers and prospects on agentic AI across the full software delivery. Most of you have heard about GitLab. Is the one that's not owned by Microsoft. And it's really the full end-to-end software delivery platform, end-to-end orchestration from plan to code through deploy, everything across the full life cycle. So I've been with GitLab for about 2 years. Prior to GitLab, I spent 12 years at Citibank, responsible for developer experience across 30,000 developers, where I also spent a lot of time with our Citi venture colleagues working with startups to help them figure out what does it take to really be successful at a large global enterprise.
Amazing. All right, well, let's dive in. Let's sort of start with that biggest pain point. A lot of startups have working prototypes or demos that they've built to start, and now they're looking to shift that into production. So I'd love for you to each talk a little bit about what's the biggest difference between that prototype stage and a production-ready multi-agent system. Maxim, maybe we start with you.
Yeah, I think the main thing is that just when you code a prototype, POC, you kind of think about happy path, right? You don't think about resiliency, you don't think about scale, you don't think about all the failure modes, and you have high stakes, right, in production. So you actually affect real systems. You talk to the system can talk to real customers, so they can change data, and I think this is the biggest thing is that when you build frameworks, and especially like usually these people who are building those, they are not like hardcore backend developers. They end up making a lot of assumptions. So like most, for example, agentic loops out there are ephemeral, right? They don't persist state, and especially multi-agentic systems, they tend to be long-running. So any failure practically can lead to a very bad situation. So I think that is kind of one of the main issues which we encounter, like for our customers when they come to us, is that they kind of playing with it is one way, but running these things at scale at production reliably is another.
Makes sense.
What I would say is that when it comes to agents, my experience is focused on agents in the software delivery lifecycle. That's what we are doing a lot at GitLab. And when we talk about agents, it's kind of similar to what happens within the traditional software delivery lifecycle. It's just compressed. You still go through kind of similar phases: plan, code, build, secure, govern, and deploy. And you still have to bring it all together from a traceability perspective. So where did everything start? What is the plan? What is the user story? What is the epic? What is the specific work item you're working on? Then link it back to the code, to the build, all the way to the various scans, verifications, and the security environment. And this is important, same way for agent and for agents to build secure and reliable software. This gets even more complex when you start to think about multiple agents. So for example, you may have a planner agent and a developer agent and a tester agent and a deployment agent. And then all of these agents have to communicate with each other. So it becomes around agent orchestration and bringing the agents together at sitting above the typical software development lifecycle loop. So I think one of the things is this platform orchestration layer on top of the agents, bringing it all together.
Yeah.
And just from the things that you actually need: traceability from idea to production, observability, keeping an eye on what the agents did, auditability, governance. Governance is a big one. You have to insert a number of control steps in the process and the workflow that both traditional employees and team members do, as well as agentic workloads.
Makes a lot of sense. I mean, software development is a huge area for this today. It's the biggest area so far, so that makes a lot of sense. Akash, welcome. Maybe you can briefly tell us a little bit about Velum, and then give your own answer for, what does it really take to kind of make that production-ready multi-agent system?
For sure. Sorry about the slight delay, guys. Thank you for having me, Jamie, and nice to meet you, George and Maxim. My name is Akash, co-founder and CEO of Velum AI. We're building personal intelligence for everyone, and what does that mean? It's a 24/7 ambient entity that is meant to help you. It's your own personal AI that does things for you both in a work and non-work context. And we're on a big mission, so it's pretty exciting what's happening. But the demo to production gap is real. So our take on this, we've seen this live over and over again, is what goes in the context window. A demo is actually pretty easy. It's one user, 5 tools, maybe 2,000 tokens in the context window for a model, and obviously it's going to work, right? But when you enter production scenarios, you have like 10 integrations, 200 tools, 50 skills. Your context window suddenly becomes 150,000 tokens. And then the model, like without doing anything, quote unquote, gets dumber because there's context rot. There's so much going on in the context window. So how does the model decide what to do? So the skill in the production gap is figuring out, like surgically figuring out what is meant to be in the context window. So some tips for this. One is like automatic compaction of the context window. So as it gets longer and longer, you can like start compacting it. Second is tool responses can be super long. So you can just offload them to a file system and so that they're not in the context window and retrieve them when needed. And the third thing that sometimes we do is we don't load all skills into context window because our system has like over 200 skills. We just provide a one-line description of what the skill is so the model can choose what skill to call and then load it into context. So just being thoughtful about what goes into context makes it like more and more production ready because in the demo, it's super easy. It's a small context window.
Yeah, that's a huge challenge for sure. And so that makes a lot of sense to work to manage that better. OK, well, then let's switch gears. As people talk about AI development, there's a lot of focus on the model. But often the challenges really come when you move to production more with everything around the model, the system around the model and the infrastructure. So Maxim, as AI agents are a new component of this distributed system, what challenges do you see startups facing when integrating this new type of component, and how does Temporal help?
I think you just need to think about, again, reliability and think end-to-end. And what happens is that as with any distributed system, right now, there are not that many high-level abstractions to help you there. If you look at almost any big distributed system, you end up with just a hodgepodge of components, right? Like you get queues, you get databases, you get event-driven systems, you get callbacks, and you kind of try to tie it all together.
Yep.
And in case of agentic system, you add sandboxes, you need to manage them, right? You kind of need to start thinking about checkpointing. And so all this kind of reliability happens in the practical application layer, right? So your harness kind of becomes this distributed application, and usually people don't think about that as kind of from the first principles and end up with just kind of in the mess, or just system which has all sort of failure modes. And with temporal, because temporal is just provides reliability and resiliency out of the box. So if you build your agentic loop right away with temporal, you kind of get the durability and out of the box. So you just don't need to think about all these failure modes because it's taken care of on the platform level.
Yeah, I mean, that's huge. That's a huge challenge, I think, than tons of our customers face. But I think the other thing I often hear from them is the challenge of sort of, how can I trust this? How can I trust that I have quality, get to quality, and be able to have confidence in that? Is that something that temporal also helps with?
Yes, but it's visibility. Practically, you cannot run any system without having full visibility into what's going on, especially with LLMs and tool calls and all of this, like everything being so dynamic. You absolutely need to see what's going on. And with temporal, you log every request just by design, and every LLM invocation is logged, every response, every tool invocation, and you have full state. And you can reproduce everything, you can roll it back. So it's kind of giving you just visibility into the system and ability not only see what's going on, but actually do large-scale changes in production reliably and securely. That is what allows you practically to run that. And also, as data is there, you always can run post-analysis. So obviously, things like evals are possible out of the box. Kind of.
Okay, yeah, that makes a lot of sense. That presents new challenges when it comes to code. As you have these agents that are now writing code, creating their own tools on the fly, compiling them and other things. How do you approach that from a trust and security perspective and workflows at GitLab?
Yeah, well, AI agents are already writing code, running tests, and in many cases already making production changes automatically. But to me, it comes down to software engineering fundamentals. There's no real way to avoid that and get away from that. But it's just compressed. So when we talk about fundamentals, it's requirements, clarity, scoped business outcomes, user stories broken down into smaller tasks that can be tested and released independently. Then we go into testability, high-quality test, a good coverage. The agent work can really only be validated by the tests that are performed at the end. We also need to cover architecture, good system design, decoupled systems, scalable pipelines for all the verification steps. You have to account for security in the pipeline, so software supply chain security. Are you using safe libraries? Are you introducing any new attack surfaces in the code base? It's really about that system of record, bringing it all together for the right context, for the right traceability, for the right observability. And when it comes to actually delivering that completed work to production, you look at some of the more advanced continuous delivery practices like progressive delivery, rolling it out to a small percentage of the users, scaling from there. For example, GitLab deploys changes to production multiple times a day. And one of the things we do is really gradually roll it out to percentage of the users. Then we go back to observability, and observability, like Maxim was talking about, into the reliability of the system as well as the security. And then lastly, governance and auditability. What's inside the agent session? What are the audit trails? What are control points? In some cases, maybe human control points. And how can we see exactly what happened and why in the system?
Makes sense. How far along is that with your customers today? Are you seeing that AI agents have become first-class developers inside of these life cycles, or is it more a companion?
So the majority of the people we talk to still have human-in-the-loops reviews. So the code is ultimately reviewed by human-in-the-loop and by the team members, and the team and the actual developers are accountable for the code base. But when it comes to agents, they're already, in my view, first-class citizens in what we're seeing in the industry. They are writing a lot of the code, in some ways, all the way to production. And as long as you follow these practices that we just talked about, as long as you have a full traceability and governance, auditability, observability, I think we're making a lot of progress in that space, yeah.
Makes sense, yeah, it's exciting. Okay, Akash, at Vellum, you've built an agent harness from the ground up, really. And the space is moving so quickly. The founders are choosing between different frameworks, how to adopt all the latest standards, whether it be MCP or others, orchestration, workflows, or choosing to build direct to the infra and just go to Kubernetes or something lower level. If you're a startup building today, and when you talk to a lot of the customers you work with, what architectural decisions matter most sort of early on in that journey?
Yeah, for sure. That's a great question, Jamie. The way I think about it is that frameworks are a tool to help you get to the desired outcome. There's lots of frameworks out there. They come and go. But usually what I recommend to people is thinking about the user problem and what are the different kinds of abstractions you want to create, intentionally the abstractions you want to create that will be resilient as your system grows and scales. So I break down these abstractions into 3 different buckets. One is what does the model do versus what's deterministic. Now, obviously, the dream is that the model does everything, right? But there's some things the model shouldn't do. The model should not be touching credentials. The model should not be on the permissions layer, and maybe a few more things like that. So deciding what the model does versus does not do is the first abstraction, because the model is excellent at coming up with UIs on the fly, coming up with novel user experiences, coming up with great responses, picking tools. The model can do so much. But there's some things the model should and should not do. Within that, that's the next abstraction is which model to pick. Now, in an agentic system, there's so many different choices that you have. You have a memory system, you have a planning system, you have tool calls, you have the actual conversation itself. There might be some other UI treatments you want to do around the main conversation. So there's many different sub-processes going on at the same time. And deciding what model to pick for each task is super important. I would not recommend just choosing one model or one model provider for everything. Being agnostic and deciding what to pick is, again, the decision of whoever's building this product. And the last abstraction, I would say, is the context abstraction, which I touched upon briefly earlier. But again, remember, context is a very scarce resource. So deciding what goes in and out of context is super important. And if a framework helps you with any of these 3 decisions, then please go for it. But again, thinking backwards from how you want the user experience to work and what the model does versus doesn't do is extremely important.
Makes sense. Would you also add sort of the tool calling aspect to that as a separation from context, or do you think of that as part of the context
Tool
piece?
calling is part of the context, yeah. The tool responses, you can choose to offload to a file system if you'd like, if they're not needed, but tool calling for sure.
But in terms of actions and such, yeah. Okay. All right, well then let's zoom out and talk a little bit more about the AI agent tech stack. Beyond the model itself, we started to talk through a bunch of these pieces, but we've got memory, tool access, evaluation, orchestration, observability, the context management. I'd love to hear from each of you in the past maybe 6 months even. What is the piece that kind of became the most crucial and non-optional that you're seeing right now? Feel free, anyone who wants to jump in to start.
I think one thing which is clear is that LLMs becoming smarter, right? And we've been talking about agents for years, but I think right now we are actually getting to the point when people believe that they are real, right? You actually can put real use cases in production, which also means that you have longer sessions, right? And you have more interesting tools. And the other part is obviously sandboxes, as practically all the code, especially coding agents, we kind of started to. It wasn't clear a year ago that the file system is the abstraction, right? And right now it looks like a lot of that is practically centered around file systems, around bash commands and others. Maybe it will go away, right? We don't know how long it will, because we can train model not to use file system, but at least right now it looks like everyone is converging that. And what we see is that in our users and customers is that just managing sandboxes at scale right? And is non-trivial task, right?
Yep.
Like we have customers which are practically, okay, what if I have 10 million sandboxes running right now, right? And I have failure modes around that. And then I need to actually orchestrate other things around them. And then it practically goes around the whole other part, which is about tools, like MCP, for example. Initially was just designed for practically run inside of IDE, right? It never was meant to do stateless, like it never was done for scale, right? You cannot do, they just add on stateless sessions, it's very stateful. And then they just introduced task. But before that, you couldn't have a tool call which takes like 3 hours, right? It just wasn't impossible. But in real life, you always have tools which take long time, and especially humans in the loop, and you need to do all sort of workarounds for that. And this is, I think, one part which you need to start thinking about, okay, these things are long running, they can fail, they orchestrate real infrastructure, and you need to have practically a system which encompasses all of that.
Yep, makes total sense.
So I'll just add that what we're seeing, especially as it comes to software delivery, is coding was never really just the bottleneck. It takes about 20 to 30% of the time in the software delivery lifecycle. And we've been talking about that at GitLab for several years now, that if coding is getting much faster, we have to consider using AI across all stages of the SDLC. So now you have multiple agents. So you have a planner agent to help you with the planning stage, a security agent to help you with addressing and triaging security issues. And now you have to think about that agent orchestration across multiple agents. And especially as you go from the individual developer workstation with tools in the IDE and the CLI to the team level and to the enterprise level. So now you elevate and talk about not just individual agent orchestration, but platform level orchestration across multiple teams, across the enterprise, keeping in mind various standards around traceability, observability, governance, and control points across that. So it's really the platform-level orchestration with governance built in.
Yeah, I think I'm just going to build on all of that, right? So what we already know and talk about a lot on the agent tech stack is memory, tool calls, evals, sandboxing, orchestration. I want to introduce a new concept, or something to just strongly consider, is a robust permissions layer. So people may have seen these tweets in January about dangerously skip permissions, and people are joking around about how they use Cloud Code at scale. Yes, it's valid that some people do that, but people developers who are building their own agents should be very careful on how permissions are collected from the user. Because again, as we all know, agents take actions in the real world. They can make tool calls, they can send emails, they can review your bank statements, and the list goes on. They can run bash commands and stuff. So now what's the right UX balance? Having a yes-no permission dialogue every single time could be annoying for the user. Dangerously skip permissions could be risky for the user. So what is one supposed to do? My advice here is, again, something that we're implementing as we go along, and it's really complicated, is basically coming up with a robust permissions and trust layer, which determines, based on various heuristics, both deterministic and non-deterministic, on how risky an action is. That can be classified into an enum of 1 to 5 scale. And based on that, you can then decide how you want the user experience to work. So in our case, for example, if there's background tasks running, maybe a low risk or medium risk task is okay to run in the background. But for a high or very high risk task, you would want the user to actually approve everything that's going on. So really thinking about how to collect user input while performing agentic actions is a new and emerging concept that is increasingly relevant.
Makes a lot of sense. So I think that's good for the infra. We've kind of covered that quite a bit. I think switching now to you've each had really successful impact at the startups you're at and in your careers. The space is moving so quickly, and the capabilities are growing so quickly. These models are, as you said, Maxim, getting much, much smarter at a rapid pace. And we've got a room full of startups and others, kind of viewing remotely. As they think about the focus of the startup and where they invest and what they're working on, what would you advise in terms of where the startup moat comes from? Is it in the data that they have, how they design the workflows, their infrastructure work, the user experience, something else? Like, where's sort of the puck going here? How do you think they should be thinking about, where to build that moat?
One thing is, some people think about that like agents will replace everything.
Yeah.
I just don't believe that. I think the kind of mental model which I read somewhere was agents will kind of replace humans, right? But humans still use systems, right? Like, for example, you have ordering system,
Sure.
or you for example, you make transactional system which makes like money payments. I cannot imagine like that agent every time will just call a bunch of tools every time deciding what to do when transferring money from one account to another.
Yeah.
You still will have deterministic part of your system which is kind of coded. And obviously we'll use agents to code it, but at the end you want to have that part, right? And the agents more like humans, and they replace a lot of humans just orchestrating those things.
Sure.
And if all you're doing is just agent with some context, and yes, data is important, and data will help you to have some moats, and in some areas it's very, very important. But I think that other part is important. And then like tying all these things together reliably, obviously, and providing awesome user experience, and especially in some vertical domains, I think that is where like a lot of companies will appear.
So is that focusing on building the systems to support that, or are you more saying, as a startup is looking at implementing for a certain scenario, build the logic and sort of system into how the agent gets used for that scenario?
I think both. Like obviously, you need, like I think the one thing is you obviously need a system.
Yeah.
Question is, will it become commodity or not, right?
Okay.
Like because a lot of things are becoming commodity very fast, right? Like and the question is, will it become commodity and will be just like, for example, Google and like other cloud providers providing all of that versus your startup doing that.
Sure.
But obviously, if you have some obviously industry-specific use cases, and then you have a bunch of kind of again business logic, which is much less dynamic and much more kind of more traditional way, I think this is where your moat will be. And I think that combining these things in non-trivial ways and new ways, this is where the power is, right?
Yeah, okay, that makes sense.
Yeah, to me it comes down to 4 items. The first one is the deep domain expertise, understanding the problem space, understanding the solutions. Number 2 is access to the right data. Number 3 is understanding and designing the workflows, the correct workflows that will optimize the solutions. And number 3 is really using all those 3, the domain expertise, the workflows, and the data, designing a really good customer user experience. I think the user experience and elevating that will make a big impact, hopefully to all of us as users and customers as well. All of that needs to scale, so the infrastructure we talked about earlier is important. But domain expertise, right data, workflows with proper guardrails and control points in them, and then unique, great user experience.
Yeah, I mean, domain expertise feels like such a crucial part and such an opportunity right now. If you really know the space and you also know the technology and AI and where it's going, you have a superpower. So it's a really exciting opportunity. Akash?
No, I want to build on that. That's like so spot on, right? And maybe taking it a bit more macro, like, okay, starting December, January, February, in the last few months, model capabilities have gotten really good. We can't really like debate that, and they continue to get better. So if we step back and think like, what are we good at? What are humans good at? What will white collar work kind of look like? I think it falls down to things like judgment, like knowing what to do, having the domain expertise, having the technical expertise to build the right orchestration, having good taste and creativity, like figuring out what the right UX looks like and how to build the best possible product experience. And finally, agency, just moving fast. That's what it takes. And I think startups and companies at large really exist to solve a user problem extremely well and extremely like in the best possible way. That's how you end up creating value for the user. So what does it mean for startups today? Know your user, solve their problem extremely well, build a differentiated user experience, and do it quickly. I think quickly is like underrated, honestly, because as models, again, as agentic coding gets better, as the software development lifecycle changes, there are really like new ways of moving fast. So an example of what we do is a bunch of our engineers, we haven't rolled this out to the whole team yet, but a bunch of our engineers have their own personal assistants that they've built on our product. These personal assistants are orchestrating Claude Code and Codex sessions while we're sleeping. So literally these personal assistants have so much context and so much memory about what our company is, what the roadmap looks like, how to build this product. That we keep giving more instructions as needed, but they can just write the code when we're asleep, and the product is building itself, which is kind of nuts, but that's kind of what it takes, moving fast and solving the user problem deeply and building a great product.
Amazing. All right, so then I think last set of questions for me, we'll do sort of a rapid fire round, and shortest answer wins. So try and keep your answers short. Right after that, we'll go to questions. We have probably about a good 10 minutes left for questions after this, so please be ready with questions in a couple minutes. So to start first, what's the biggest mistake that startups make when building systems built around agents?
Yeah, from my kind of point of view is that think about that they're distributed systems, right? They're building distributed systems and just think up front.
Right.
And also, again, it's very easy to get very immense scale with AI. And we've seen examples when companies scaled like instantaneously almost. It's unprecedented.
You have to plan for that.
And you should kind of be ready for that. Like this old style of build something and then you will rewrite it next 3 years. If you're successful, just doesn't work. You will be just killed.
Yeah, makes total sense.
I see all the time when worked in a large enterprise, not considering security and governance constraints within a large enterprise. So that I'll keep it short. That's it.
100% agree, though. That's great.
I'll go back to what I've been saying. I think the biggest mistake is treating context like it's free. Yes, context windows keep going up, but context is a scarce resource, and using that wisely is a big mistake that people make if they don't do it correctly.
Okay. Number 2, what part of the AI stack will break first as agent usage explodes?
Yeah, assuming that we have explosion of user agents because LLMs are good enough, so then I would just go back and say infrastructure, right? That you need to make sure that you run them at scale reliably, and also they become more and more long-running, so you need to think about that up front.
Is that just, doing so requires being comprehensive on all the parts of how you scale, or is there a piece of that breaks first?
It's an interesting question about, I don't think it's just scale, it's about reliability, right? Like you don't want your user hanging there waiting for response, or just a model doing something which you don't have visibility into, and then user comes, like we had cases when, and guardrails and stuff like that.
Makes sense, okay.
And not so much that this will break, but I feel like there is a lot more work we need to do as an industry in evaluating and testing that something actually works the way we expect it. And then even benchmarking that it works consistently from release to release of the agent, from version to version. This idea of properly evaluating, getting confidence that it's consistent from release to release. I think as an industry, we've got a lot more work to do to be comfortable and confident and scale that. So not necessarily that it will fail, it's just that we don't know how well it's doing.
Yeah, you have to be able to observe it, you have to be able to evaluate it, et cetera. Yeah, it makes sense.
I'm going to build on what Maxim said. I think tool calls hit real infrastructure limitations with rate limits, with credential rotation. What happens if you run into errors? How does your system handle that? And errors will happen as you scale.
Totally. OK. Last one, and then we'll go to audience questions. What will an AI engineering team look like in 3 years?
Interesting question. I think that we still will have humans, but most of the code will never be read, right? Like I think most of the code will be generated, and at least at application level, I don't think anyone will read this code. And humans will be both maintaining the harnesses around that and like agents around that which are producing that and putting rules in place and so on. And then they will be obviously become like project managers, product managers, right?
Yeah.
They will be just and make architectural and product decisions, but not low-level decisions.
Yeah, highly technical product managers not reading the code. Got it.
It's a very interesting question, and the answer evolves every 3 to 6 months. And people are thinking about what's going to happen to my job, to my role. So my point of view is that the job market will evolve, but they will actually as it becomes cheaper and easier to build technology and software, the demand is going to grow. That's what we're seeing with our customers. The backlogs are not actually decreasing, they're increasing, and there is more work to be done. But the nature of the team will evolve. It will be smaller, more integrated teams. I think previously we talked about the pizza-sized team, 8, 7, 8, whatever is the right number for people being fed by once. pie of pizza, but just going back to a smaller, more integrated team, and also the skill set is going to be more combined. So product management will be big. We talked about deep domain expertise, but also still some dev, test, core software engineering, and then the SRE and the reliability and running at scale. So all of that coming together, so definitely smaller, more integrated teams, but I'm not convinced of that single person team. I think we always need multiple people with different creativity, reviewing each other, helping each other.
Yeah, exactly. Teams will get smaller. Each person will, each role will become more and more full stack, and not by full stack, I mean not in the traditional sense, front end, back end, infra. It's more like understanding the user problem, building the software, and then testing it as it goes out. Because ultimately, the job of the whole engineering and product function is building a product to meet the user requirements, and writing code is basically an implementation detail and has been for decades. But now it's all collapsing, and the faster you can get to market with a small team with domain expertise, that's what winning teams will look like.
Amazing. All right. Well, thank you. Thank you, Akash, Maxim, George. This was really helpful. I think it really drilled into some of what goes into the challenges of moving from prompts to production and the evolving space of how quick things are moving. So thank you very much.